All right. Hello, everyone. I'm Amitabh, and I like to make stuff. Some of the stuff that I have made is a height sensor for elephants. The green thing that you see over there is a 6.5-foot PCB. The final version was a 13-foot PCB that took me about a dozen movies to solder. Interesting experience. Um, I made Supersuit, which was kind of like laser tag for the 21st century. I embedded sensors and lights into concrete, and of course, I made a concrete soldering stand for my soldering iron. But today, I'm here to talk about Programmable-Air, which is an open source kit for controlling pneumatics for soft robotics and inflatable soft robots. What is soft robotics, you ask? That's not it. Soft robotics is the field of robotics that deals with making mechanisms out of highly flexible materials. And it's seeing growing applications in industrial automation and for prosthetics. I started Programmable-Air in Carrie Love's soft robotics class. Carrie literally wrote the book on soft robotics. And for the final project, I wanted to make something like this. This is a crawling soft robot that came out of Harvard back in 2011. I was like, wow, this thing moves so animated, and I just want to make something like this, and I started looking into it. Turns out it's pretty simple to make something like this. You can just 3D print a mold and pour in some silicone, and yeah, you can make something for $100 that's as good as something coming out of a top-tier university. But it's controlling the soft robot that's very difficult, and these were kind of the only two controllers that I could find, and they're like designed by researchers for researchers, $1,000, big, clunky, difficult to use. And so I decided I want to make something for hobbyists to control soft robots with. Did some research, designed a circuit board, did some prototyping, and pretty quickly I had a working prototype. And I could inflate and deflate a balloon. So at this point, the engineer in my brain goes, good job, task done, let's move on to the next thing. But where I saw just a balloon going, inflating and deflating here, my friend Kim saw a sculpture. This is Foxy Lovelace, a sculpture about female sexuality with accentuated lips, which it does not allow you to touch. When you approach it, it blows a bubble. And then when you move away, it sucks the balloon back in. So I was like, yeah, okay, I'll explore some more. So it turns out, pneumatics is pretty fun. You can make a pick and place machine pretty easily. So suddenly the speed of making boards went up by 50%. Pneumatics is counterintuitive as well. This tiny pump can lift me up. Just put a Ziploc bag under your feet and it'll just lift you up. Like, it's insane gear ratio. Anything that has air becomes a sensor. So this is Mr. Piggy, generally a squeaky toy, but currently controlling these lights. And the cool thing is that it's very scalable. Like, you can totally imagine this squeaky toy being replaced by a bouncy castle, and suddenly the lights are in sync with your jumps, right? It's like, yeah, that's cool. I should share this with people. So I took it to Maker Faire, where people seem to like it. I got some validation. The maker community seemed to like it as well. So I was like, yeah, excited. I was like, okay, open source all the way, write down all the documentation. I made the code super simple, like literally just blow, suck, vent, read pressure, and you can start controlling your soft robots. By the way, you guys, dark theme on the Arduino. Get with the dark theme on the Arduino IDE, please. It's just like, my eyes. Okay. So I documented it really well, and this was one of the happiest days of my life when I just typed Programmable-Air into the Arduino list of managed libraries. And I was like, oh, wow, look at that. My thing is on Arduino. And I put a website up, and I was like, all right, now people will start making their own Programmable-Air boards, and they'll start making fun projects with it. But of course, things don't work like that. Turns out if you want people to use your things, you have to sell it to them so that they can use it. So I started manufacturing this thing by hand in my tiny New York apartment, my nice little Black & Decker, which if you set to medium toast, then it bakes PCBs pretty well. And pretty soon, Programmable-Air was all over the map, literally. Shipped it out all over the place. And importantly, people used it to make interesting projects. Enough interesting projects, in fact, that when I tried to put all of them in, Chrome crashed. So this is not even nearly all of them. And there's no way that in this talk I can do justice to all of them. So instead, I'm gonna just give you a flavor of what some people have made using Programmable-Air. Arnav, who's a friend of mine, made Flexo. Flexo are plug-and-play soft actuators for the VEX robotic system. And so with that, you can, for example, make this grabber, and it's gonna pick up this thing and then move around a little bit and controlled by Programmable-Air. You might have seen this hand in the demo upstairs or on Twitter around, also made with Flexo. This is Julia. She made a silicone heart as a part of her ongoing artistic practice called Mechanics of Being Human. And she controls it, the beating of the heart with just Programmable-Air. Rashida made Birthday Cake 3000, which is a birthday cake with some straws and edible glitter inside them. The entire cake is a capacitive touch sensor. So when you cut it, it sends out a little puff of air and edible glitter just out of the cake. The name 3000 is for the 3000 milliseconds of delay between you cutting the cake and the air coming out. Like, yeah, edible pneumatics, that's interesting. LD made an inflatable bra. Turns out 25% women suffer from asymmetrical breasts. And her project aims to make a breast that's like adjustable so that it supports both breasts equally. Aditya, who I couldn't find a photo of, makes origami. He invented that origami Doctor Strange there. But we worked together to make an origami gripper based on something that came out of MIT Media Lab, MIT C-Sale in March of this year, and turns out like very easy to make. Something that can that weighs only a couple grams but can lift a kilo of weight. So yeah, these were some of the interesting projects that came out of. Now, if I had my speaker notes, I'd know what to say here. So we know some of what is possible with Programmable-Air. Let us now see how it works. Pneumatics, as it turns out, pretty non-trivial, and for some reason or the other, not yet embraced by the maker community. So it was a lot of like figuring out things as I was going. So how do you control a soft robot? It has one line of tube going into it, and you want to be able to push air in, pull air out, and read the pressure and let it exchange air with the atmosphere as well. So this is kind of what I came up with. You have a compressor, which is trying to push air in this direction. You have a vacuum pump, which is trying to pull air out of it. This is a valve that will allow air to pass in this direction. This is a valve that's closed, and it will block any passage of air. That's your soft robot, and that's a pressure sensor. Okay. So now let's say I want to push air into my soft robot. I can have this connection, and now this valve is open. This compressor is pushing air into my soft robot. Then if I want to pull air out of it, I can switch on this valve, close this one, and now my vacuum pump will pull out all the air. And then if I switch on this valve, I can let it freely exchange air with the atmosphere. And all the while, this pressure sensor that's always connected to my soft robot through a single tube is giving me feedback on what the state of my actuator is, right? And this is something that I like to call full channel air control. It's not something that I've seen used anywhere else, so I kind of invented it, I guess. But I like to think of it as the base of the very base of the most minimal thing that will allow you to do everything that you want to do with your soft robot. You cannot remove any of these components and have a fully functioning system. So for example, people have tried doing things with two-way valves and reduce the number of valves required, but then that doesn't allow you to be able to close all of these valves and completely switch off your system. You cannot remove the pressure sensor, for example. If you remove this atmospheric pressure valve, you lose the ability of compensating for the changes in atmospheric pressure. With this, what you can do is, like, in the beginning of your code, you just switch on this valve for a few seconds, take a few air pressure readings. Everything is based off of that threshold pressure, and your code works the same whether you're in Portland or in New York or on the top of Mount Everest. So this is programmable air. It's based on the same full air channel control. So you have these two pumps. They pump. They can act as compressor or vacuum pump. So they pull in air from one end and then push air out of the other end. And then you have these three valves, and they allow you to control your soft robot. So some interesting design challenges came as I was designing programmable air. These pumps, for example, you might not have seen them put on a circuit board like this ever before. And that's because they're not meant to be mounted like that. And when I did mount them, they would the leads would just tend to vibrate and break off. So I was like, okay, I can put some hot glue below it and just glue it to the PCB. And that worked fine for a couple of months. But then the motor gets hot and eventually cures the hot glue into a thick, dark brown material that's not sticky or vibration dampening at all. So now I'm using silicone. I was like, pneumatics is difficult, you guys. Electronics themselves, by itself, is difficult because, when you're designing a system, you have to make sure that all of your components are rated for the same voltage values and the same current values. Pneumatics, especially electropneumatics, adds the fact that they have to support the same pressure range, the same flow rate, and then they have to have the same nozzle size, right? And so try as I might, I couldn't find a way where some cheap components would fit in together with the same nozzle size. So for example, my pressure sensor had this really tiny nozzle and everything else had a bigger nozzle. So I was like, okay, I know Fusion 360. I'll design this adapter that goes on top of my valve, and then my thick tube will come in here, and then a tiny tube at the bottom. I was like so happy with myself. Yes, I designed this system. And then I had a good night of sleep, and then I realized this is what I should be doing, which is this is a little tube of a different diameter that I just put on the pressure sensor that increases the thickness of the pressure sensor, then put in my tube and then just zip tie it. And that works so much better and is so much cheaper. Yeah, and I wanted things to be just like, good, easy for the user to use. For example, these buttons are color-coded. There are a few buttons on the back as well, and they're all a different color. So that in the tutorials, I could just be like, press the red button instead of press button number 2, right? And turns out there's just one factory in China that makes like colored buttons that are this tiny, and I had to track them down, and they're giving me these buttons as a loose bag, right? Not on a tape and reel that I could feed into a pick and place machine. So paying extra for that, but I think it's worth it. I think that not enough development boards, well, maybe now they do, but a year back, not enough development boards had some kind of user output. So I put some NeoPixels so that the user could, just quickly see some feedback from their system. And then, of course, things I thought were not hard enough already. So I made it harder on myself. So version 0.5 and 0.6 look pretty similar, but in 0.6, all the capacitors are oriented vertically, and all the resistors are oriented horizontally. Did I need to do that? Not at all. I'm so happy that I did it. So much more elegant. Nobody knows the difference except for me. Yeah, so I feel like all the engineering challenges have been solved, and Programmable Air is live on Crowd Supply as we speak. And you can go on the website and purchase it, and it comes in this beautiful foam case, which honestly I'm sometimes more proud of than I am. Again, not my laptop. Which one? Okay. Yeah, this case took a lot of late night WeChat conversations. But yeah, and you can make some little soft robots with the kit. But a great product is just that. Any open source project really depends on the community. So I've been taking workshops and just talking to people about how they can use pneumatics in their own projects. And I've been writing tutorials um, on how to make some soft robots. And I've been trying to work with some other organizations, Open Soft Machines, for example, based out of University of Tokyo. They make these amazing recipes for soft robots that you can make out of just polyethylene tubes and Ziploc bags. And we're working together to make programmable air, open source, open soft machines kits. No worries. And then my friend Joe from Protosauce invented probably the most flexible 3D printing filament. And we're working together to make a service where you can essentially design your soft robots and get them 3D printed directly to you without ever having to do any assembly, touch silicone, or do anything else. So yeah, that's something to look forward to. Last month, NASA tweeted this thing about using soft robots for exploring space, and I was like, whoa, yeah, that's great. More people should get into soft robotics. And then when I looked into the blog, I saw this ridiculous mess of a thing that's like multi-$1,000 equipment controlling this pretty simple soft robot. So I was like, no, you guys, do it this way. So that's a very similar soft robot being controlled by programmable air. And yeah, I hope that more of you think about soft robotics the next time you want to get some linear motion. Instead of thinking about a lead screw, think about a syringe. So yeah, that's me. I'm all too happy to learn more about your projects and talk about how you can incorporate soft robotics in them. Yeah, at this point, I'd love for you to ask any questions if you have them. Thank you. Yeah, okay. So, yeah, see, this is one of the things that I totally forgot about mentioning because I didn't have my slides. One of the big things that went into programmable air was mostly the whole of the project, the engineering design, was just cost reduction. So the pumps, for example, are pumps that are used in blood pressure cuffs and breast milk pumps. And they are, because they're generally used in the medical industry, they're pretty high grade, and the rubbers and all the flexible material that's used in there is pretty insensitive to chemical reactions. The valves that I'm using are used traditionally in Keurig machines, so they can handle water, they can handle steam, they're pretty robust. So I wouldn't be surprised at all if you just hooked up a propane tank to it, that you'd be able to handle it. The pressure inside, I don't know about propane particularly. I know butane, the pressure isn't all that high. It's not much more than 1 atmosphere overpressure. So the valves can definitely handle it. Yeah, and I like the direction that you're thinking. But I will not be legally liable for anything you do with that.
Smart man.
Yes.
Here.
I didn't get a chance to look at the API very closely. When you do the blow and suck, can you control like how strongly, or is it just on off?
Mm-hmm. So you can control the speed of the motors and essentially how quickly the motor is pushing air or pulling in air. The valves themselves are just on and off toggle valves, and it takes about 20 milliseconds for them to, from you saying, toggle to them doing the thing. So you can't like PWM the valves and work that way. You can do, what you can do is, so pneumatics, excuse me. The analogy of electronics to pneumatics translates pretty easily. So motor is essentially a battery or a pressure source. A tube of a particular diameter has a particular resistance, and any volume of air is essentially capacitance. So when you want to get, when you want to convert a PWM into an analog value, you use a capacitor, right? Similarly, if you wanted to get a particular pressure, just attach a Coke bottle to act as a capacitor, and then just switch on and off the valve to get a particular pressure output in the bottle. Yeah.
I was just curious. So during your inventing process and figuring out how everything was going to work, were there any resources you used as informational that you found really interesting? Maybe scrolling through patent information that's available to try and find ideas and niches and corners? Or was it mostly just trial and error?
Yeah, I'm trying to think back. This was almost a year back, so it's difficult. Mostly what I did was because the patent information is great, and I did a lot of that, but it doesn't translate. At the end, it was just a race to reduce cost. I knew this things was possible because there were products that were doing that for $1,000. So for me, it was important to just tap into mass markets. So basically, most of it was just scrolling through Alibaba and AliExpress and just, being like, okay, this is this, and just ordering dozens of pumps and valves and being like, does this work with that? How much pressure can it support? And these things don't really have data sheets. So it was like, okay, I hooked this up to that and that leaks. So probably not compatible. Yeah. Cool. If there are any more questions, I think we can take them outside as well. Oh yeah, that's the most important question. Yes, you have 3 days, 4 days to act. 4 days to act, you guys. Buy it now. Okay. Thank you very much.